Good morning. How's everybody this morning? I'm starting a new project in the shop. I just thought I would maybe share a little bit of it because I don't share a lot of information here. But um, let's just get into the Jeremy Schmidt um, belt grinder. I'm sure you've seen a lot about that if you follow the metalworking community. A lot of people have built this. Here's what it looks like. Um, on his website, you can buy the plans here. It goes from Etsy. But this is basically what it looks like, and I've been putting off building this for a long time. But he's got the new generation drawings here now, so he's upgraded. Um, I guess he's fixed a lot of things he didn't like the way it was. So you can look on YouTube under Jeremy Schmidt, and he's got, I've got it on the screen over here I've been looking at. So I've been watching this. It says in 2017 he did the first design, so he's went through and fixed a lot of the things that he didn't like about it, simplified things, and probably took a lot of people's opinions on that have sent him messages about how to do things easier. But anyway, I'm not gonna show you, I can't share the plans with you that I bought, but you can go in here and buy those um, in either metric or imperial drawings. And see, you can buy the plans. It's $28 to buy the plans, and you can watch the video, uh, which could be really helpful. I'll show you some of the plans that I've got just to explain which route I went. Now this is a very expensive build. The motors are very expensive. The VFDs are really expensive. Um, there's other videos out there of different kinds of motors and VFDs that are cheaper than this, but this one is expensive. So I'm going exactly by his plans. Here's the PDF version of the plans that I bought. And I'll just kind of show you a little bit about, just showing you how good the quality of it is without sharing a lot of the details of it, because I'm not allowed to share this. I can't send you the file or anything like that legally. So, and you can email him with any questions. But I don't know him personally. I've just watched the same videos that you've seen about this. So he talks about using the Leeson brand of motor, and then the KB Electronics VFD. So you're using a three-phase motor, and I like to use the 240 volt on anything I can in the shop. Just a little less current draw and possibly a little more power that way. So what he did talk about is use the 1750, 1725, 1750, whatever they call it, RPM, to give you a little more power on the low RPM range. But with the VFD, you can still overspeed that up to 3,000 or 4,000 RPM. So I would do that. And you can also, he also says in here, if you want to, you could just use a single phase motor with a switch, on and off switch. So you're going to be stuck at whatever RPM. It goes 1,800 or 3,600 RPM. So that's another option. But I'm going exactly with the stuff he did. That way, if I have any issues, I can easily either look in the plans and get the information, or email him and get any questions answered about that stuff. So anyway, they're just material lists. I also, besides the PDF here, he sent Dxf Files, so I cut these parts on my CNC plasma 3/8 plate. So far I've cut a lot of those. This is just a list of the things you can shop for. I went ahead and ordered these aluminum wheels that the belt runs on. So I ordered a few things from McMaster Car. Just for instance, I'll just briefly tell you, with McMaster Car, I haven't bought this wiring yet, which I'll probably get that, from local Ace Hardware or Home Depot, or I may order it on Amazon for, I don't know. But McMaster Car, I spent $68. Amazon, the wheel kit was 123 bucks. There's no way you could probably even buy material and bearings and stuff and build those for that price. It's a 5-inch wheel on the motor with a 5/8 bore that's broached for a 3/16 keyway. And then I think it's got a 4-inch crown for the I forget where that's the tensioner part, I think. Anyway, and then you got some of these nice handle bolts to tighten things up. Anyway, all that was 68 bucks plus 123. The VFD, which I got this on Amazon. I shopped, and Amazon, these things are the same on Amazon as they are anywhere else from what I could find. So, the motor was $570 total. The VFD was about $381. It's very expensive. I'm going to plan, I bet this is going to cost $1,500 to build this. That's probably silly to spend that much money and build it yourself, but I kind of want to do it. So anyway, and then there's Bolt Hardware. You can pick this stuff up at Tractor Supply. They're usually the best place around here to buy bolts. They sell them by the pound usually, so it's fairly inexpensive. And here's the cut list. Again, this is not really showing you any details of the plan, because this is not exact specs here on how to build these, but I'm trying to be correct here and not share more than I'm supposed to. So I cut these on the plasma table. I'll show you some of this stuff out there. I'm probably going to make a few parts of this video possibly and just share a little bit about what I'm doing. I guess if you need me to cut any of these parts for you, just contact me. I'll see what kind of deal we can work up. If you otherwise, he's got these templates in here that you can print PDF files. One thing, the most complicated part that I've seen so far that I need to build is this 2-inch square tube. You've got to cut it in half basically and put an angle on it. So cut the top of it out right there. I'm thinking about a way to do that. I think maybe I'll plasma cut that down to leave a little more than 1 inch. I think it's supposed to be a 1 inch tall when you're done here. I may plasma cut that in a fairly straight line and then put it in the mill. Maybe put a block of wood in here to make that secure in the mill vise, and then maybe mill the tops down flat to the right dimension. I think that'll work. Of course, I can cut that angle before I do any of that. Before I mill anything, I can cut that angle with a bandsaw or chop saw or whatever. So that's probably the only thing that's real difficult that I see, other than plasma cutting parts. If you don't have a CNC plasma table, that could be a chore, or a CNC mill would do it as well. These DOM tubes that it talks about, I'm probably not going to mess with ordering any DOM tubing. I think I'll just machine these. There's not very many of them. They're just short pieces for spacers and things. I'll just put them in the lathe and turn them and drill them or whatever I need to do on those. It's not a big deal there. But here's the printable templates. This is one for the table. So the way he made these, you can print these and cut them out and stick them down on your material. And if you wanted to bandsaw these out or whatever, you could cut these out. And remember, I also have the Dxf files, but these are nice because they show dimensions and things if you did want to either draw them up to do your own CNC work, if, you know, for whatever reason. But he gave me both files, so I have all of it. For 28 bucks, it's pretty reasonable. But I'm not going to show you every one of these because this would be sharing the drawings that I pretty much swore I wouldn't share. So just going down the list, I'm just mainly showing you how well this is laid out, the steps of how to assemble it. You know, I've bought drawings in the past that didn't give you much information other than the parts dimensions, and this is nice because it shows kind of how to lay it all out and the best ways to build it. And watch his YouTube video. He shows building this with his own plans and cutting it the old-fashioned way with bandsaws and things like that. So anyway, if you have any interest in building these, I'm not really a how-to video. I'm just sharing what I'm doing. I'm not real big on this tube, but he talks about building the tube out of plate or flat strap 3/8. I don't like the looks of that. I wish it was just a nice tube, but I think I will go ahead and do this. And I thought about if I welded this together, I might could even I'm not sure I'll do this or not, but you could weld this together and then put it on the mill and chamfer the 45s on the edges, and then even if you wanted to then take a grinder and just radius the edges to make it look like an actual tube, which I have seen a video of a guy doing something similar to that. Not on this build, he was building a whole different type of belt grinder, I think, but not sure of that. But anyway, that's enough of that. I just want to show you what I'm doing here. I don't stretch this video too long. This is an overview of I'm just sitting at the computer here looking at some of this. And here's some of the files that I have. I think on his website, I already showed you that, didn't I? This is straight in his website. This is GERSwoodshop.com. This is Jeremy Schmidt. You can go in his website and see all the, he shares a lot of stuff in here about it, kind of what it looks like and things that he's changed about them to make them. There's so many attachments he's built and designed to make it more versatile angles, and this table will turn any angle, horizontal, vertical, any angle in between, and all the different fixtures and things that he has drawings on and videos on how to build these things too, to make it a really versatile tool that I'm always just need a quick grinder, and I don't like the regular belt grinder. Is kind of, I mean, bench grinder, you know, is with a rock is just kind of rough, quick, not always useful. This is pretty useful because it just works good. You can put different belt grit and everything else for doing metal, wood, or plastic, or whatever you want to grind on, really. So I thought I'd show you what I've got done so far. Is just the first part of the overview of what I'm going to do. This is going to take me quite a bit of time. You know, I usually work 50 to 60 hours a week at my day job, and so I'm pretty limited on the amount of shop time I have. I'm going to have to go out of town today to get a little bit more materials, and just to show you, I wanted to show you he also has drawings on his website of those wheels if you wanted to build them yourself. Of course, you could build them anyway yourself, but material is going to be higher. I wanted to show you those. He had a file in here of, well, there's the wheels in the PDF form. The belt grinder wheels. One design is to have a steel bushing in the middle. But that's kind of how it sets up, and that's the tensioner. Not the tensioner really, but the tracking device. You screw that in or out to easily adjust your belt. This type of spacer between the bearings I don't really care for, but it would work. honestly, I would just bore the hole smaller than that, just the space between the inner race of your bearings to keep from crushing in on those when you tighten them up. Which you probably want to use lock nuts on that anyway, so you don't have to really over torque them. And of course, that's a crowned wheel on your drive wheel to make the belt stay put. Anyway, there's a lot of useful information here. I'm not going to go in and waste a lot of time talking about this. I'm just showing you what I'm building. And then we'll go out in the shop and I'll show you what parts I've already cut and the motor and VFD and that. And then I got to go get cleaned up and go to about an hour away to my metal supplier and see if I can round up the rest of the pieces that I was going to need to build this thing. So let's just go out in the shop and see what we've got going on there. So out here in the shop, I kind of laid up some of the parts that I've been making. I don't know how well you can see them, but some of these, you know, these are plasma cut 3/8 over here on the plasma table. And normally overcut the holes by about 45 thousandths, and then sometimes I have to take this little burr wheel and just touch them just a little bit, just to make the bolts go through them. Like this one, for instance, is a pretty small part. You usually get a little bit of taper cutting thicker material, but anyway, see the bolt goes through there just fine. And I didn't cut any holes that need to be tapped, of course. But anyway, I think in the plans he shows cutting that one off so you can get that on a smaller piece of material, but I have the file to cut it all in one piece. Some of these are a little tricky, you know. If you need me to cut some of these, just holler at me. I can cut these for you. These are all pretty difficult parts to make if you didn't have a CNC of some sort. I mean, you could do these on a rotary table on a mill. Yeah, it'd be a lot more trouble. These just cut out real quick and easy on the machine. Some of these I have a little bit of errors with because I was using little pieces of material and I was running close to running out of material. In fact, there's some over here on the, I'll show you. I was going to recut a few pieces. It doesn't matter that much. I mean, you could grind them and probably use them, but I thought since I got a little bit of this material, yeah, I just had a few little pieces of 3/8 I was trying to use up and cut these out, and some of them kind of moved. They was close to the edge of material or whatever, and well, that one came from over here. So I thought I might just recut this, or I could just grind that smooth, but I think I'll just recut it since I got room somewhere here. I can just recut a couple pieces that I don't like. Got a little notch, probably wouldn't hurt a darn thing, but heck, I got this little bit of material left. Might as well go ahead and recut a few of these since I have the material right there. So anyway, I was just going to show you, yeah, I got a tree over there I got to plant. I'm waiting on the last freeze to be over with. My wife ended up with that tree from a leftover from a estate sale that she doesn't even know what kind of tree it is, but almost looks like a pecan tree. I'm not sure. Now here's the expensive motor and VFD that I got. I don't know how close you can see it. This is a real high quality VFD. It's pretty heavy. Let me get over here and see if I can. I'm not sure how well you're seeing this stuff, but I don't know. This thing has a heat sink, and I think it's enclosed pretty dang good to keep dust out of it if you use the proper ways to get your wiring in here. And it has some upgrade places you can put switches for forward and reverse and different things. I'm not even sure how all this works out yet. But I don't know, this feels like it probably weighs maybe 20 pounds. It feels pretty heavy. And here's that expensive motor, that Leeson 5/8 shaft, 3-phase, 2 horsepower. I think it says 17, I don't have my glasses on, 1750 RPM, something like that. And there's the handles. that I got from McMaster Car. Just a little bit of hardware. Went out and got this from them too. It's a cast, I think it's zinc coated steel is what it is. I think that's where your spring mounts to. I got the spring and all of that from them. That's the exact part number that he had mentioned, and these, which I think he said he cuts these off to whatever length it needs so it don't stick out so far. And there's one female one that goes on something I forget. But of course these are made where you can adjust them, you know, they're spring loaded. So you can adjust the handle position wherever you want it to be, you know. Okay, and then here's those aluminum wheels I was telling you that I went ahead and ordered. They look like good quality. I mean, I don't see anything. It's a 5/8 broach keyway already in it. And you know, there's where your set screw is. Right there to go on your motor shaft. And then, of course, it's crowned, and this one's also crowned. This is 4-inch on your tensioner tracking, the tracking part of it. And then on the platen, whoa, I dropped everything. The platen has 2 of these, and they shake because there's a spacer in there that when you put your bolt in there, it lines your spacer up with your bearings and everything. So I'm pleased with that design. I mean, the quality of all of this stuff looks good. You know, yeah, I'm spending quite a bit on it, but I don't really have, I found one more, I need a lot more, quite a bit more 3/8 to finish some of the plates to cut. I found this piece of 3/8 out there in my pile, and it's pretty pitted up. Not real bad, but you know, I may use that. I may go, when I go look for metal in a while, if it's not too expensive, I may buy, if they got 8-inch flat bar, 3/8 by 8-inch would be nice if I had a piece of that. If I can buy a short piece about 4 foot, maybe 10 foot long, I could cut the rest of the parts out of good clean metal and not have to deal with that. But anyway, that's kind of where I am. And if you don't follow me very much on my channel, I mean, this is just about sharing shop stuff. It's not how to, and I mean, there's no sense in criticizing me for how dumb I am. I'm a machinist, CNC machinist at aircraft manufacturer. Only been there about a year. I have my own machine shop, hobby machine shop here with full-size mill and a 13 by 40 lathe. I'm definitely not an expert on this, but I do whatever I need to do in my own shop. I've got tons of tools and equipment of all types here. Doesn't mean I know how to use them that well. I've got a TIG welder there. I've got a Lincoln MIG welder over there. And I've even got a Lincoln portable gasoline welder for outdoor use. I don't do much stick welding anymore, but I've got the Lincoln Power MIG 256 right there. That's only a couple years old, I guess. If that, maybe less than that. So cutting torch I rarely ever use anymore because I have the plasma table and I have a hand torch that I keep hanging up here that I use occasionally for mainly cutting scrap pieces up. But this is the hand torch that goes to the plasma cutter, and a big mess everywhere else in the shop, as you can see. Of course, I've been in the automotive business forever too, so got my own lift and, you know, tons of tools and everything to do all that with. So anyway, I appreciate you watching this first part of this project I'm getting myself involved in. It's going to end up costing a fortune, but I want to do it. So follow me for the next part, and we'll see how much we get done here in the next week or two. Thank you. See you later.